If you are a mutually exclusive event, what that just means is you can't be both things at one time. If I flip a coin, it's heads or tails. It can't be heads and tails. Guys, shh. Right? Does that make sense? Like, so flipping a coin or flipping, a coin twice, that's mutually exclusive events. You cannot be both heads and tails at the same time. There's some other examples like, what did I write down? Okay, if you ask to pick a number, pick a number between 1 and 10. Okay, the probability that it's even versus the probability that it's odd, those are mutually exclusive. You cannot be both even and odd at the same time. So if you take the probability of even and odd, it's going to equal 0 because that's impossible. You can't be even and odd at the same time. The probability that you're going to go adopt a pet and it's going to be a cat or a dog, it can't be a cat and a dog at the same time. Yeah, it's not possible. It can't happen. Yeah, so we're talking about things that are like really impossible, and those are mutually exclusive events. These are things that cannot be the same, or two different things at the same time. It used to be, back in the days before Starbucks and things like that existed, you either had coffee or you had hot chocolate. They were mutually exclusive. Now you have a mocha, and it's this, it's basically coffee and hot chocolate together, so things can change. Some weird scientist somewhere might make a cat dog. I don't know, but for right now, it's a cat or a dog. I mean, no. When we draw a Venn diagram of mutually exclusive events, there is no overlap. So, like on the homework where we had those questions about students that care about uniforms or not, things like that, you can't have a situation where you're one, you're both. Like, if you have to choose between chocolate ice cream or vanilla ice cream, you're not allowed to pick both. You have to choose between chocolate or vanilla. Then you'd be in either A or B. There would be no swirl. Like, the swirl doesn't exist, let's just say. So, so it's like this too. If we're picking a card from a deck, event A is choosing an 8 and event B is choosing an ace. They're not going to overlap because you're not going to get an 8 ace. Right? There's no overlap there. Now, if event A is choosing an 8 and event B is choosing a club, you could pick one that's both because you could have an 8 of clubs. But if you have something that's impossible, like one is choosing hearts and one is choosing spades, you can't pick a card that's both a heart and a spade. It doesn't exist. So that's when you get those mutually exclusive. And again, the probability of this, where you have the and, which, remember, it's this symbol here, the upside down U, is 0. And then the probability of either or, you add the two probabilities together. And we haven't talked about adding probabilities yet, but we'll do that. Okay, what is the probability of randomly picking a number from 1 to 10 that is even? So that's A is an even number between 1 and 10. And then B is an odd number, 1 to 10. Okay. This is an OR. When it's OR, we have the probability of A or B. So that's going to be the probability of A plus the probability of B. Okay, the probability of A, well, let's look at our even numbers. Even is 2, 4, 6, and 8, right? 2, 4, 6, 8. So there's 4 out of 10. And B is odds. I have 1, 3, 5, 7. Oh, I forgot 10. Duh. Sorry. Apparently I can't count. 5 out of 10. So I have 5 evens and 5 odds. So when I add those together, I have 10 out of 10. So my probability is a 1. So I have like a 100% chance of getting an even and an odd. Two fair dice are rolled. That means it's separately. The fair dice just means like you're just rolling them and it's a fair roll. They're not loaded dice. They're not special weird dice. They're just 2 dice and you just roll them. Okay. What is the probability of getting a sum less than 7 or equal to 10? So I've got these tables. This is how you do these. We roll 2 dice. If you get 2 ones, your sum is 2. If you get a 1 and a 2, your sum is 3. If you get a 1 and a 3, your sum is 4. A 1 and a 4, you get the idea? This is like a sum table instead of a multiplication table. Make sense? Okay. Now, if I look at how many sums I can get, I have 6 this way, and I have 6 this way. So I have 36 total possible sums. Okay. If I count up the ones less than 7, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 possible sums that are less than 7. So far okay? So the probability of a less than 7 is 15 out of 36. If I have equal to 10, there's only 3 of them. So that's 3 out of 36. And again, I have the word or. And because I have the word or, that means I use the addition. So probability of A plus the probability of B. So that gives me 15 over 36 plus 3 over 36, which is 18 over 36, which is 1/2, which is 50%. So I have a 50% chance of getting below 7 or equal to 10. Chosen randomly from a standard deck of cards. So remember, standard deck, we have 52 cards with 4 suits, 13 of each, and 3 face cards, Jack, King, and Queen. Okay. So, yeah, standard cards don't have the jokers in them. So what is the probability that a card chosen is a diamond or a club? So the probability of a diamond is 13 out of 52. Okay. Probability of a club is also 13 out of 52. Again, we're using the word or here. You'll notice I haven't had you calculate the probability of a card that's a diamond and a club. You don't have to calculate that. I said, what's the probability you're going to pull out a card that's a diamond and a club? And you're going to say 0. And I'm going to say, yes, you are correct. Good job. But probability of a diamond or a club. So we've got the probability of diamond or club is 13 over 52 plus 13 over 52. That's a 3. So that's going to be 26 over 52, which is 1/2. So you actually have a 50% chance of pulling out a card that is a diamond or a club. If you think about that, that kind of will make sense because there's 4 set suits, right? Diamond and club is half of them. So you have a 50% chance of getting that, if you think about it. Are they mutually exclusive? Yes. You can't be a diamond and a club at the same time, so they are mutually exclusive. If you can be something at the same time, so back to our chocolate and vanilla ice cream, in the modern day, you have the knob in the middle that'll swirl them, right? You've got chocolate knob and a vanilla knob and a swirly knob. So those are not mutually exclusive because you can be both. Your ice cream cone can be chocolate and vanilla. But you cannot be a club and a diamond at the same time. We're going to toss 3 coins at the same time. So you're just throwing them up in the air and watching them land, okay? What is the probability of getting 1 or 2 heads? Okay, so if I throw 3 coins, for coin number 1 I could get a head, and coin number 2 could be a tail, and coin number 3 could be a tail. Or I could get a head and a head and a tail. Or I could get a head and a head and a head. Or I could get heads, tails, heads. Or I could get tails, heads, heads. Or I could get tails, heads, tails. Or tails, tails, heads. Or tails, tails, tails. Okay, so those are all my choices, and basically what I did is I have 4 where the heads was the first coin and 4 where the heads was the second coin, and then I figured out the other coins from there. So we want to know 1 or 2. Okay, well here's 1, and here's 1, and here's 1. So out of my 8 tosses, I have 8 total possibilities. 3 is with 1 head. So the probability of 1 head is 3 out of 8. And then we want to know for 2 heads, this one has 2, this one has 2, and this one has 2. So that is also 3 out of 8. So the probability of getting 1 or 2 heads is 3/8 plus 3/8. So that is 6/8, which is 3/4, which is 75%. So the probability of tossing 3 random coins up in the air and getting 1 or 2 heads is 75%. Are they mutually exclusive? Can you be a head and a tail at the same time? No. So yes, they're mutually exclusive. And that's all you have to ask yourself. If you're asked, are these things mutually exclusive? Can you be both at the same time? If you can't be both at the same time, then the answer is yes, they are mutually exclusive. Sort of like mutually exclusive, except they're inclusive. Okay, here's some example. Rolling a die and getting a 4. And then rolling again and getting an even. These are mutually inclusive because a 4 is even. So you can be both an even and a 4 at the same time. Does that make sense? Another example would be pulling a card that's a spade and pulling a jack. Okay, mutually inclusive because you can be a jack and a spade at the same time. So exclusive, you cannot be both at the same time. Inclusive, you could potentially be both at the same time. Because things can be inclusive, which means something can be both at the same time, you have that overlap. And when we have that overlap, anything in the middle could be potentially counted twice. Because if you count it as group A and you count it as group B, then you're counting it twice. Does that make sense? And so what we end up with is we have the addition rule for probabilities of inclusive events, which is where we take the probability of A, we add it to the probability of B, and then we subtract the overlap. And the overlap is that and portion. Okay? Because that way it prevents us from double counting. Because what we want is essentially, we want all of this plus just this right here. We don't want to count this part twice by counting both circles fully twice. But when we calculate the probability of A, we're counting the whole circle of A. And when we do probability of B, we're counting the whole circle of B. And so it's getting counted, that middle part's getting counted twice. We have to subtract it and take it away once. Does that make sense? Because it's in there twice, so we take one of them away, then it's only in there once. Okay. So that's what this formula right here is. This is the one you use for mutually inclusive. Sorry. So we wanted to say, what is the probability of choosing a card that is a club or a 10? Well, you can be a 10 of clubs, right? So you can be both at the same time. So this is an inclusive. So again, we take the probability of A plus the probability of B, and then we subtract the probability of both, that overlap. Okay, so the probability of A, we'll say the clubs are A and a 10 is B. There are 13 clubs in a standard deck of cards, so the probability of, 13 out of 52. Okay, so that's the probability of being a club. And the probability of being a 10 is 4 out of 52, because there's 4 10s. Now the probability of being both, a 10 of clubs, how many 10s of clubs are there in a deck of cards? Just one, right? So the probability of being both is just 1. So to find the probability of the event, which would be AUB, is 13 out of 52 plus 4 out of 52 minus 1 out of 52. So 13 plus 4 is 17, minus 1 gives me 16 out of 52, which will reduce to 4 13ths. And if we wanted to do that as a percentage, you have about a 31% chance of drawing a club or a 10 out of a deck of cards. What is the probability of choosing a number from 1 to 10 that is less than 5 or odd? Okay, so if we look at less than 5, we have 1, 2, 3, 4. If we're looking at odds, we have 1, 3, 5, 7, 9. And both 1 and 3. Okay, so both less than 5 and odd is 1 and 3. So we want to know the probability of picking a number from 1 to 10 that is less than 5 or odd. So if I call this A and this B, the probability of A, which is the less than 5, there's 4 of them. So it's going to be 4 out of 10. And the probability of B, there's 5. So that's going to be 5 out of 10. And the probability of both, so both less than 5 and odd, there's 2 of them. So far okay? So then the probability of choosing a card that is less than 5 or odd is going to be 4 out of 10 plus 5 out of 10 minus 2 out of 10. So 4 plus 5 is 9, minus 2 is 7 out of 10. And then, of course, if you wanted to know that in percentages, we would divide that, and it gives you 0.7. So you actually have a 70% chance of choosing a number that is less than 5 or odd. We have 2 dice. What is the probability of getting a sum less than 7 or less than 4? Okay, so I'm going to make that table again like I did, but I had it typed out. I'm going to show you guys how to make your own table. And it doesn't really take that long, even though you go, oh my gosh, that's a lot of adding. 1 plus 1 is 2, then you get 3, 4, 5, 6, 7. 2 plus 1 is 3, 4, 5, 6, 7, 8. 3 plus 1 is 4, 5, 6, 7, 8, 9. You just count at that point. This is 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, 12. So yes, it's a lot of numbers, but you don't actually have to do all that adding. You just count across. So we want to know how many are less than 7, we'll call this A, and less than 4 we'll call B. So the probability of less than 7, I have, here's my 7 line. So less than 7 is all of these. $15. So we're going to have 15 over a total of 36 because there's 36 sums. And then the probability of less than 4, just those ones, yeah. Now, we have to say, what is the probability of both A and B? Being less than 7 and being less than 4. Well, no, because if you're less than 7, or if you're less than 4, you are also less than 7, right? So this original, or this 3 right here that's less than 4 is also less than 7, so they get counted right there. 3 out of 36. Does that make sense? So our probability of A or B is 15 over 36 plus 3 over 36 minus 3 over 36. So basically, that canceled each other out. Because if you're less than 7, you're less. If you're less than 4, you're already less than 7. So, you know. So you have 15 over 36, which gives you 5 over 12. And then if you wanted to know the actual percentages on that, you would divide those, and you get 42%. Scrabble, basically. 26 tiles with a single letter on each. 1 for each letter of the alphabet. What is the probability of reaching into the bag and randomly choosing a child with one of the first 10 letters or a vowel? Okay, the first 10 letters. So we have A, B, C, D, E, F, G. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the vowels, A, E, I, O, and U. Sometimes why?
Why don't count for time?
Yeah, why doesn't count for the probabilities? They don't count it. Okay, probability of both. If you're a vowel and you're in the first 10 letters, you have A, E, and I. So, yeah, so the probability of getting the first 10 letters is 10 out of 26. because there's 26 letters. The probability of a vowel is 5 out of 26, and the probability of both is 3 out of 26. So I take 10 out of 26, I add the 5, and I subtract the 3. Yep. And when I reduce that, I'll get 6 over 13. And again, if you want to know what the percentages are, you divide 6 by 13. So 46% roughly.